keyboard anymore. Okay, earth science time. Right now we're going to talk, this is how we, I made that E in a way that I don't usually. I'm not going to write earth science. I am going to write earth science. I'm a little bit confused. Give me a second. I am going to write earth science because we're learning in earth science today about earth science. This is meta earth science. And we are having fun. And we are about to spill all of our business onto the floor with the poorly made music stand. And we are using an almost dead marker. So let's get all that stuff corrected. Earth science. Today in earth science, we're talking about earth science. Specifically, we're talking about how we go about doing the business of earth science. Okay, let's start with I'm going to pitch you a low ball here, or a slow ball. I don't know what you say. I'm not good at sports analogies. What are we going to be talking about mostly in earth science, do you think? And it's kind of a trick question, but not super. Earth, yes. Also space. This is earth and space science. And systems. I do want to point that out. The earth system. Okay. For the next 3 months, we're talking about, that's an inside joke, but we're not really going to spend that long. But what is a system in science in general? What is a system? You can see it's one of our CCCs. We talked about SEPs and CCCs last week a little bit, right? There's that board up there. Do you see that one of the CCCs, one of the cross-cutting concepts, one of the things that applies to all science is that fourth one, the blue one, says systems and system models. What's a system in science? Let's define it. You should have remembered it from your explanations. Oh, where'd that come from? Define system for me. Let's all together define system. And you're adults, so let's not just read the definition of system from the book, the explorations. Does it say up there? I'm going to read it. I'm going to move over here, and since I have my backpack mic on, I can do that. Oh, that's a great definition. The definition given by this, which I love, but I want us to think of our own version of it. A system is an organized group of related objects, components, and models can be used for understanding and predicting the behavior of systems. Okay, yep. Let's start with that. Different things, she says, that have something in common. No, I'm not. This is not mocking you. I think this is really good. Different things that have something in common, working together to trail off. Doesn't really matter. The rest of that doesn't matter. But it could be different things. Well, let's do a definition by example. What are some examples of systems that are not the Earth system? Let's think of some other systems that we know about in science. Remember, this applies to all science. It's a cross-cutting concept. Systems applies to all science. What are some other systems in science? Some famous ones. You know. What are some things that have the word system in them? The ecosystem. Okay, an ecosystem. Good. What's another one? This solar system. Let's have someone who isn't Kyla talk for a second. Working together to... What are some other systems in science? Marissa, what is one? There's a lot of other ones that have the word system right in them. Think about your little body. Not you, Carla. What? Let's be more specific. Okay, good. Thanks, Camden, for saying that out loud. The nervous system is one of the systems in the body. Oh, yeah.
It can also be the cardiovascular.
Yeah, there's loads of systems. There are loads of systems in your body. There are loads of systems on Earth. The universe is full of systems of, what do these all have in common? Well, they're all different things that have something in common, working together to. And in fact, do they have to have everything in common? Are they always the same? No, they maybe have to have something in common. They're all part of that system, but they're more or less different components working together to. And the only part of this, Kyle, I like this definition. The only part I have even a little bit of trouble with, I like this because it makes it easier to understand for lay people who don't know about science. But the reason I kind of revolt at it a little bit is because it implies that they have agency, which means like it implies that they're all like Mercury and Venus are like, hey, let's work together to get this done, when that they can't think, obviously. So as long as we remember that the objects in a system can't always think, and in fact usually can't, and usually have no agency, this is a good definition. So what are some components of, specifically now, we're talking about the whole thing, or the more specific thing, the Earth system. What are some components of the Earth system? What systems make up the Earth as a system? That is, what things that are themselves composed of components working together make up the Earth that all work together? We sometimes call these the sphere, yeah. The geosphere, biosphere, I know the rest. I do know the rest. I'm just making sure that this is actually part of what we're supposed to be talking about in this explanation, because we kind of got a little bit carried away, or I should say I've kind of gotten a little bit carried away. This is actually part of lesson 2, but that's okay. This will be the lesson 1 and 2 discussion. Yeah, there is a lithosphere. We usually, in this context, we usually include that as part of the geosphere.
And the
Atmosphere. I'm looking for one more. There are others, but I'm looking for one more specifically. What are some other important things? We got the dirt, the life, the rock, which is part of that. The hydrosphere. That's the other one I was looking for. Good job. Hydrosphere. And this, like I said, this is all from actually lesson 2. But as an example, they certainly are Earth's systems. They are systems that are on Earth. They work together to make the Earth as we understand it. Your book also brings up this idea of a phenomenon, which is very important to us in science. What is a phenomenon?
It's like an idea or a claim, but it doesn't have any evidence to back it up.
It can involve that. I think it's less. Let me say it's less personal than that. Like it doesn't rely on a human being to think about it. A phenomenon is
Just like something inside.
yeah, exactly. I love that. We're going to write that down. I thank you for always saying the things that I really want to write down. A thing in science that happens. Here's what I love about that, little babies, is that this makes it super accessible. Anyone can understand this. A thing in science that happens. Is the tree a phenomenon? Yeah, there's a tree. That is a thing in science that happens. Is the flag a phenomenon? Sure, yeah, the flag is waving right there. That's a phenomenon. Don't get confused because I just told the freshmen this morning. Nope, I just told the 8th graders this morning. Was it the freshmen? And was it yesterday? It doesn't matter. My life is all a blur. Someone said lightning. Yeah, lightning is a phenomenon, but it doesn't have to be lightning. It doesn't even have to be as exciting as lightning, because when that person says lightning, another person said something exciting that happens in science, which I guess depending on your definition of an exciting is maybe true, but it doesn't have to be exciting. The confusion is that sometimes we use the adjective version of this, phenomenal, to mean something really good, like Tristan, that's a phenomenal shirt, that really good shirt. You know, like you've heard people say phenomenal, meaning it's really good. You did a phenomenal job on your test. In our vernacular, in our layman's parlance, we use the word phenomenal to mean something really good. But phenomena doesn't have to be good or bad. There's no judgment value, and it doesn't even have to be exciting. There's no judgment value on this at all. It's just a thing that happens in science. I was going to say an occurrence, but that's a little bit hoity-toity compared to this. Why did we include in science? Isn't everything science? Is everything science? Okay, let's be more specific about what science is and is not. What does something have to be considered in the realm of science? What is science all about? That's exactly what I was hoping to say. Evidence. Evidence That's kind of like our step 2 of what we said was a scientific method. I can't remember if that was in here. I said this same stuff so many times this week, it's mind-boggling. But we did talk about scientific method a little bit? No. Did we?
Well, we know what a scientific method is.
I'm going to give you my brief, boiled down, distilled 3-step version of the scientific method. I like this. I think it's true because it helps us to understand that we're all scientists, that we don't have to be doing clinical research and writing 25 long page papers and getting a PhD to be scientists. We're all scientists. What I consider the scientific method at its very core to be is recognizing a problem or asking a question, but there's some kind of spur, there's some kind of impetus that something is different. It could even be an observation. So I'm just going to put here inquiry. Something has caused us to ask a question, or to make an observation, or to wonder if, blah, 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 blah. Second, we have an investigation. Can it be a clinical trial? Sure. Can it be an experiment? Sure. Can it be an experiment with a setup, independent, dependent variables, a lot of constants, and a control group? Absolutely. Does it have to be those things? No. To me, research is investigation. Like my example of, I did talk to you guys about this, because didn't I say well, you guys are on the way to Westco and you see a snake? Nope, that was the 8th graders. Did you watch that video though? I don't know what's going on, don't at me. Let's say, try to make a new example, it's more fun. You're at the golf course, like some of you are, sometimes, and you see a neat plant. That happens to you, right, Tristan? You see a neat plant, and you say to your buddy, what kind of plant is that? That is science. I saw a neat plant. What kind of plant is that? What are you going to do? What are you really true? Yeah, you're probably going to Google it because you're Gen Z, and you're going to use that as a verb. You're going to say, I'll Google it, and then you put your little phone up, and there's actually a really good app. It's not even an app. You can just have, I think Siri even will tell you what kind of plant it is if you just make her look at it. We found that out at Upward Bound this summer. But that's an investigation, and that counts. To me, that counts as scientific. You will definitely find someone, college professor maybe, maybe not, someone who's in the field of science, like an actual researcher, that says that's not real science. I don't know. I'm not going to fight them about it. But to me, this is science. To me, you are a scientist. That's a neat plant. What kind of plant is that? Oh, you saying that to your buddy is communication, and that's a key part of science. So let me be clear. The scientific method can mean different things to different people. Science itself, we try really, really hard to make it not be able to mean different things to different people. We like for science to be unambiguous, but the scientific method itself is kind of a matter of opinion. That's why this is a valid scientific method. The 6 steps hanging on the door to Mr. O's room in the lab is a valid scientific method. That one includes form a hypothesis, perform an experiment. The 5-step version that is in my physics book is valid. The 12 steps that you may be learning in 6th grade, that's valid. Because it's not really as like counterintuitive as it is, the practice of science is not a science. Like we don't have to apply scientific principles to this practice of science. To me, this is the core of the scientific method. So a thing in science, a thing with evidence, we have to be able to actually investigate it. So what kind of things are not science? Not science. What kind of things can we not have evidence for and therefore can't investigate? Say them, don't be scared. I'm thinking of 3 or 4 major ones here. What are some things that are not scientific because there can't be evidence and they can't be replicated or investigated? I hate meatloaf. Is that science? No. So opinions are not science. You can't provide evidence that I do, I mean, maybe you could, but it wouldn't be actual scientific evidence that I don't like meatloaf or that meatloaf is better. Value judgments, that kind of thing. Opinions, value judgments are not science. What else then? There's a contentious one that comes up a lot. What is it that is not science? That is contentious, like people fight about it. religion is what I'm getting at. Religion is not science. And that's not a value judgment. Just because something is not scientific does not mean it's worthwhile or useful. This, by its very definition, it's a system of beliefs. It's a system of personally held beliefs. That cannot be science. There can't be evidence for those. And usually, almost always, it's supernatural. Supernatural, by definition, is outside of nature. That's what supernatural means. And so it cannot be within science. That doesn't mean, that doesn't mean this is incompatible with science. In fact, in most cases, it's very compatible. In fact, they can help each other out in your little brains. It can help, the human experience can be helped by having both of these in conjunction with each other. But it isn't science. We don't apply the same principles to religion and opinion and art, is the other one I was getting at, that we do to science. They're just different realms of existence. And you could even make the case that a person's life would be hollow without all of these things. Well, for one thing, without your science, you wouldn't have TikTok. Without art, how useful you could have a life without art, but that, like Mr. Smitley does. But it's not gonna, it may not be as colorful as some of the rest of us who do, like at ericsnitley.com, I don't know. No, he will probably be the first to admit that. He probably would have admitted that earlier than I would have. What is another key part of a system? What do systems often or always do? All of these things, they work together. You could even make the case that they're harmonious, but they're always changing, which is another of our CCCs. Stability and change is another CCC. They all change. All of these, I did it off the spheres, but I meant to do it off of all systems. Systems change. So evidence is what determines if something is scientific. And science is the study of phenomena and how they change. And those phenomena working together, remember they can't actually think, most of them, but those phenomena relating to one another is a system. And everything is full of systems. I feel like I kind of barely let you guys get a word in edgewise, but do you have questions about this? This is your time to share your findings. Your explorations obviously went into quite a lot of detail about this. Usually, I think, in my reading of this, mostly examples, I would say. To me, what I wrote up here is kind of like the kernel or the seed within it, and then the rest of it was just like examples around it, like talking about ice core samples and coral bleaching and stuff, just providing examples. Is that what you guys think too? Do you have any thoughts? Tired. Your thought is just tired. Okay. Okay, me too. Okay, hearing none.